Okay, so where we stopped yesterday, as we started getting into the idea of a z-score, what we got to realize is that these plethora, these infinite number of normal curves all follow the same pattern that you're starting to see with the empirical rule. But in order to do that, we need to kind of bring them all back to a standard curve. And that's part of the reason that we have this idea, this thing called a standard deviation. It helps us do this. So the process of standardizing scores, um, basically, what you're going to see is any normal distribution can be converted to this standard normal curve by using a z-score. So here's the formula for the z-score. X was your observation, and then mu was your population mean, sigma your standard deviation. So we'll play around with this thing in just a minute. You'll see how it plays out. But the value, what you saw yesterday in that activity, the z-score, it's basically how many standard deviations are these observations from the mean. So the first type of question that you could run across, the question might read something along the lines of what proportion of observations are so and so, or find the percentage of these that are between two values. But typically, what's going to happen is you're given the mean and the standard deviation. So what you guys need to do is first we got to write a probability statement in terms of some variable x, and we'll make sure that we define x, and we'll walk through one of these in just a second. We're going to draw a normal curve and shade, and this is just to give us kind of a sense. We can start, if we do this, we can use our empirical rule and our knowledge of the empirical rule to kind of guesstimate before we get the actual value, just to make sure we're going in the right direction. Then we're going to find the z-score and the probability. And this normal CDF, this is what you see right here at the bottom part of number 3. This is what we're going to use the calculator for. So you're going to need a TI-83 or 84. And then at the end of the day, we want to make sure we come back and we write our answer in context. So it's not going to be just a single 0.28, 0.26. We want to make sure that what does that 0.28 mean? What does that 0.26 mean? And so we'll just jump into a question here. So you got a question here on a old basketball player, Muggsy Bogues, used to play for the Charlotte Hornets back when they were the Hornets. Well, before the Bobcats became the Hornets, and before the Hornets were the Bobcats used to be the Hornets, so on and so forth. So here we go. Muggsy Bogues is 63 inches tall. What percent of, well, that should be men are taller than him, because we'll just go with men's heights. See, we got this. Men's heights are normally distributed there. So let's kind of pick through. And so the first thing we want to do is write a probability statement. So we're really looking what percent of people are taller than him. So what percent of people are taller than him? So we're looking for the proportion that are greater than 63 inches. We want to define x. X portion of men. So there you go. So when we look at x, what proportion of men are over 63 inches? Perfect. Next up, we're going to draw a curve and shape. So here we go with our curve. We'll draw our normal curve. There's our mean. Notice the mean is 69. And then we'll just work our way out in either direction. All right, so we have the standard deviation, remember, so this is your mean. There's your standard deviation. It's given to you. We just go out 2.8, 71.8. Add another 2.8, 74.6. Probably should have given myself a little bit more room, and then 77.4. Although we're really not going to be too concerned with being this far out. So there's 66.2, 63.4, 60.6. So Muggsy Bogues is at 63 inches. So he's slightly below 2 standard deviations. So using the empirical rule, we can start to kind of gauge. So he's at 63. And really, what we're looking for, we're trying to figure out what's the area of the curve that we shade from 63 and then on back. So again, we can kind of guesstimate. Yesterday we would say there's about 2.5% from 2 standard deviations. So maybe this is about 2%, slightly less than 2.5% using our empirical rule. But what we're going to be able to do is actually come up with the true proportion or the true percent. So we want to write a z-score. So our observation was 63. And we're going to subtract the mean of 69 over 2.8. Now, 3 minus 69 over 2.8, negative 2.14. Now, here's where we should realize. This is how many standard deviations away from the mean we are. And sure enough, 63, we've already seen it. Right? 63 is just beyond 2 standard deviations. So the z-score is matching up with what our curve is showing us. This is a good sign. Where we're going to go with the calculator in just a second. So if you have your calculator open, right above the vars button, you see distribution. So we're going to go and hit second, distribution, and you get two normal options. So the one that we want normal CDF. So scroll down and select normal CDF. And when you hit enter. Now, for those of you with the newest operating systems, you're going to get this screen, which is going to tell you exactly what you want. If you don't have this screen, I'll show you in just a moment how you're going to go about this. But if you look back at your curve, you can see that we're going everything to the left all the way up to 63. So in theory, because this curve continues on forever, this will go to negative infinity. Well, the calculator won't do negative infinity, so the way that we're going to write that, and I'll actually clear this out since it's already sitting there. I'll show you how I'll do it. We're going to go negative 1, and then right above the comma, you see that e to the 99. So basically what we're doing is we're doing negative 1 times 10 to the 99. So that's negative 1 with 99 zeros afterwards. That's a really, really big number in the negative direction. So that'll probably be far enough for us. The upper bound for us, well, where did you stop shading? We stopped shading at 63. So type in 63. Hit enter. The mean. Our mean was 69. I can actually see it right there. And then the standard deviation was 2.8. And then we hit enter a couple times. Now, you guys without the new operating system, when you hit normal CDF, you probably had parentheses that opened up. And so you would have to type these in this particular order. So you do the lower bound first. So what's the lowest the curve goes? Followed by the upper bound, followed by the mean, followed by the standard deviation. That comma, remember, is sitting right here above the 7. So when you hit enter, sure enough, well, we were a little bit off in our guesstimation, so we're actually at 1.6%. So we come back here. So the proportion of men, oh, I realized now all of a sudden I wrote that. Oh, we want taller. I realized that I've done this whole problem backwards. I'm finding the percentage of people that are shorter than him just now in the calculator. So, well, I'll do it this way. The proportion of men that are shorter than Muggsy Bogues, 0.016. Well, now this will allow me to, really this is what we wanted, right? This probability statement goes with the part of the curve that I didn't shade. I apologize for this. So really what we could do, since about 1.6% it's here, we could just do, so the proportion of men that are greater than 63 inches, 1 minus 0.016. I would not expect you to do this 0.984. I apologize for going the wrong way, but we can use the properties of a density curve. So now just go back and put your answer in context. What percentage of people? So 98.4% of people are taller than Muggsy. Really probably what we should have done, pardon me, what we should have done was shade up, right? So I've shaded the wrong direction. So you guys should have shaded up like in this particular curve. And then you could have also, in your calculator, if you'd have done it the right way the first time, you would have ended up doing your lower bound this time. We should have gone from 63 up to infinity. So the lower bound should have been 63. And we're going to shade up forever. So that's going to be positive 1. And you got to hit second comma to get that E. The mean and standard deviation is the same. That's what we probably should have done from the very beginning. 98.4%. We still got there the long way. Again, I really apologize for kind of sending you in the wrong direction initially. So the other type of question, they could ask you to kind of figure out what is a critical value. In other words, they're going to give you some kind of percentage. A lot of times these questions are going to say something like, find what value the 25th percentile is. 58% of all so-and-sos lie above or below some certain value. So we're going to draw a curve to get a sense of where we're looking at. We're going to find a corresponding z-score using a different function, the inverse norm function. I'll show you that in a second. And then again, we're going to put our answers in context. The one thing that we have to be very careful about when we use inverse norm in the calculator is that it always goes to the left, right? And I even put a note right there under the calculator syntax blank on your note sheet. The calculator only goes to the left. So if you're asked, what percentage of observations are above a certain mean, we have to just use our brains, and I'll show you one example of that here in just a minute. But you have to kind of think about it for a minute and think about, well, if 60% and above, that would mean that we're talking about the 40th percentile. So we'd have to be careful how we use inverse norm. So what is the height for a man at the 70th percentile? Right? So here's our next example. So first thing that I'm going to encourage you to do, again, draw a curve. So where would the 70th percentile be on a normal curve? Well, we know that 84th percentile is 1 standard deviation above the mean. Now, I'm still using the men's heights from above. So we'll go ahead and throw the 60.6, 63.4. I'm just going to steal my values. 66.2, 69. And that was 71.8, 74.6. And really, so 70th percentile, right? We knew that 80th percentile was right at 71.8. So 70th percentile is somewhere in here. So really what they're doing is they're telling you, hey, we already know that we've shaded 70% of the curve. And we're looking for what value goes right here. So in order to do that, the calculator can be very, very helpful for us. Again, you go into that second vars or the distribution menu, and you scroll down to the third one. Right there it is, inverse norm. Now, we're looking for the area 0.7. And if we go all the way to the bottom, what this is going to give us is that is our z-score, 0.52. So our z-score, right, so again, here's your formula, x minus mu over sigma. Well, this time, we still know that mu is 69. We still know the standard deviation was 2.8. But this time, the idea, right, is we're now starting with the z-score and working our way backwards. Right, so we can solve that algebraically. Multiply by 2.8, add 69. Right, there's one way to do it. 0.52 times 2.8. So x equals 70.46. And sure enough, something slightly below 71, right? So there it is, x equals 70.46, which makes sense. Between 69 and 71.8 inches, 70.46 follows. The nice thing about the calculator, however, is if we go back in here, you can actually put in the mean and the standard deviation from our problem, and it'll kick back the exact cutoff value, the exact critical value that we're looking for in the context of this problem, 70.468. So I rounded slightly differently than they would have, but we see we're getting the same answer. Right? One example, what are the heights of the tallest 60% of men? So again, draw that curve. And the idea behind the curve, I'm not trying to overkill here. I just want you guys to get kind of a sense of where we are. So the tallest 60% of men, think about, we know that obviously in the middle is 50%, so we just drop just a little bit, which means we're looking for that group of men. So again, somewhere between 66.2 inches and 69. Now this area is 0.6, and we're interested in finding, well, what is that cutoff value right there? So if we're going to use the inverse norm function in the calculator, we have to be careful. All right, so the inverse norm function for us, the area that we're actually interested in here would be 0.4. When we go to the calculator, we'd end up with a z-score of negative 0.25. And so then negative 0.25 equals x minus 69 over 2.8. So we can work our way backwards algebraically, end up at x equals 68.29. Or if you wanted to use your calculator from the very beginning, you could just type in inverse norm. The area we're interested in is 0.4, and then you could have just typed in the 69, the 2.8 right from the beginning, and you'd get that height. So again, put your answer in context. So the tallest 60% of men are 68.29 inches.